In today's activity, we're going to develop improved properties of parallelograms. There are really just two. To start with, identify which of these figures are parallelograms and which are not. So those that are, we're going to color in some kind of pattern, which we'll look at in just a second. So here's a parallelogram. Typical basic parallelogram ABCD, and it's colored. Isn't that just beautiful? So we've labeled it. We're going to draw one of the diagonals, in this case the long diagonal. Okay, so there's the long diagonal, and we're going to cut that. And so that we have labels on all parts, be sure to put the corners, double the label, like see there we've got at vertex B, label it on both sides, because when we draw the diagonal it splits it into two parts. And those parts are specifically triangles. Well, what characteristics do we know about those triangles? Well, let's check out this one that we've got separated. So when we separate that, that's why we had to write our points B and D twice, because when it's separated, B is part of the two different triangles. So what do you recognize about those two? Well, they appear to be the same size and same shape. Well, can we prove that? Well, as it turns out, we can prove that they are congruent. Congruent means that they are the same shape and the same size. And if we overlap these together, they will be the exact same shape and same size. So for our second, well, we'll call it Exhibit B, we'll place these two together like this, and notice that when they're overlapped, we've got the different corners and different sides that correspond with each other. Well, what does it mean to correspond? It's when you overlap them and the parts of the original figure that overlap exactly or in the same place as the other figure. So, for example, vertex A, angle A, corresponds to angle C, D corresponds to B, and B to D on the two different triangles. Well, how about the sides? Because that's what we're most interested in now. So we've got side CB in the lower triangle, and that corresponds to what side in the top triangle? Well, CB corresponds with AD. Well, there are three other sets of corresponding sides: DC in the lower one with BA in the top, and then DB on the bottom with BD on the top. So label each of those. So there we have the three congruent statements, and recognize the one at the bottom. Okay, so the third statement, which now has the right notation on it because the symbols matter. So we've got segment DB congruent to segment BD. What's special about that? Well, segments don't matter if they're written forward or backwards because they have two endpoints. So DB and BD are the same thing. So which property is that? It's your reflexive property. And so watch, if we see DB and BD are the exact same line, it's the diagonal that we just drew there. Okay, so meanwhile, back at the ranch, look at CB and AD. CB is on the right side and AD is on the left. Notice that they are opposite sides of the parallelogram. So what two characteristics have we shown so far? Well, the opposite sides, because it's a parallelogram, we know that the opposite sides are parallel to each other. And with this whole rotation thing we did and cutting it into triangles, we have proven that those are also congruent. So opposite sides of a parallelogram are parallel and congruent. And that works also with the top and bottom sides. So AB is parallel to and congruent to DC. Well, here's a rectangle. Is a rectangle a parallelogram? Well, it is, and so the properties that we just discovered for a parallelogram also work for this. The opposite sides are parallel to each other and congruent. Parallel and congruent. Parallel and congruent. Check out all these from our original diagram. Even the square in the bottom right-hand corner. Okay, in our Venn diagram of polynomial or polygons here with quadrilaterals, notice that parallelograms, everything that's within the area of the parallelograms, including a rhombus, a rectangle, and a square, all are going to fall under the properties that we discovered for parallelograms, which once again is opposite sides are parallel and congruent.